Hello guys, welcome to BYJU'S Exam Prep, the most comprehensive preparation app for all the competitive exams. So today I am going to discuss a link state routing technique. So in the adaptive routing techniques. So in computer networks. So please quickly join and mark your presence. And actually myself Murali Krishna, I will be taking the computer networks and link state routing in today's session. So under the coffee with concepts. So while you are having coffee, you can learn this link state routing very easily. So let me introduce myself before I begin the session. So myself, Murali Krishna Bokasamudram, I am having 21 plus years of teaching experience, both in the GATE and also I worked in different engineering colleges. And I am a topper of NPTEL course and certified as International Engineering Educator through ISRO certification program, and I have mentored more than 50,000 students across the country in different core areas of computer science, like theory of computation, operating systems, computer organization, computer networks, digital logic, and ICT, information and communication technology. So these are my area of expertise. And before I begin the session, so just let us see some of the slides. So there is a free workshop for all of you. So regarding how to ace the gate in the first attempt by one of our topper, Rashul Chudani. He is All India rank 12 topper in gate 2023. So this live session on 7th May, okay, at 12:30 p.m. So all of you please utilize this opportunity to register for this free workshop. So just you can understand what are the insights from All India rank 12th Rahul Chitani for GATE 2023. Okay, so and these are some of our toppers I've been telling you. So GATE 2023, plenty of ranks we got. Those who have taken classroom coaching and also exam the test series, most of them are classroom people. And 62 students who got under 50 rank, and 13 students under 10, and 107 students under all India rank 100. And these are some of our toppers. Dhruv has got All India rank 5th in computer science, and Gautam has got All India rank 1st in production and instrumentation, and All India rank 4th in the instrumentation and electrical by Sarvarma. So these are some of our toppers. So wish them all the best and big congratulations to all these people. And I wish you all the best for 2024 aspirants and also for 2023 NIELIT aspirants. So now let's start the session. So basically link state routing is an adaptive routing technique. So where we can get the dynamic information. So for making a routing from source to destination all the way. Okay, so let us suppose this is a source host and this is a destination host. So how the router is able to make a path. So by using, because routers may be of different networks, and if two hosts are communicating, both the hosts may be at different ends of the world. Okay, so link state routing basically, so the main difference between distance vector and link state is, in the distance vector only we rely on the neighbors and without having any topology, so without having any graph or a map. But here in link state routing, we should ensure that every node will get the entire topology where you are making a routing. So all the routers learn the entire network topology by exchanging messages. Okay, it will not be provided directly, it will be learned through exchanging information and sharing the knowledge. So topology will be known. So based on the learned topology, each router computes the shortest path route by using some Dijkstra's algorithm, and it requires two mechanisms. One is the reliably distribute link state information and also compute the route information. Okay, based on the shortest path tree, we can make a routing table in the link state routing. So it is actually it uses the open shortest path first. Okay, the first mechanism uses reliable flooding. Flooding is also required in order to make the topology to exchange the partial knowledge. So some nodes will know some links, some other nodes will know some links and their cost. When they exchange, entire information will be known to all by using the flooding, and they can make the topology. Once if graph is known, topology means routers and their connections and their links cost. So once the graph is known, using the Dijkstra's algorithm, we can make the routing table. We can make the shortest path, right? So features of link state routing protocol. First one is link state packets. Link state packet is nothing but information, a small packet with routing information regarding how many links are there and all. I will show you with the help of example. and also link state databases, collection of information, and shortest path first algorithm. These are the things we use. Finally, routing table is being constructed. Okay, and basically an LSP contains the following information, something like ID. So what is ID of the node, and what are the different links to the node? For example, if there is a node A connected with node B with a cost 2, and connected with node C with a cost 1. So the link AB information, the link AC information will be sent to all the other nodes through flooding. And list of directly connected nodes with the cost. AB directly connected, cost 2, AC directly connected, cost 1. And the sequence numbers also will be there for every packet. So to understand the uniqueness, and time to live field is also there for considering the age field. So we cannot keep the older packets for a longer time because of the flooding. A lot of duplications are possible. Older packets to remove. So age field is being used. And the last two fields added to improve reliability of flooding. For the implementation of flooding, sequence numbers and age field for a link state packets are being added. Okay, I will show you with the help of example, so you won't get any confusion once if I show an example. Before that, what is the reliability? Exchange of LSP with neighbors uses reliable protocol, that is called flooding. So when nodes receives LSP means link state packet. Okay. So stores if it does not already have one from that source. Say for example, one packet is received already. If that packet is available, it will just discard it. Otherwise, it will forward to all outgoing links. If it is already has that LSB and a new sequence number greater than the stored value, it will update the entry and forward to all other neighbors. So that is open shortest path first. So this example I will consider once. Let us suppose this is the graph, and A is a node B, C, D, E, and A is having three links: AB with the cost 5, AC with cost 2, AD with cost 3. Similarly, B is having BA with cost 5, BC with cost 4, BE with cost 3, like that. Some cost is there. And the link states are here. So first of all, these are the steps you can just observe. Topology of the subnet should be made available at every node. For example, A is knowing only partial information, AB link, AC link, AD link, and CE link, BC link, and BE link is not known to A. How to make it available? So by using the LSPs, link state packets. So A has a partial information, B has a partial information only about their directly connected links, and this partial information is being exchanged in order to ensure that every node is getting a same topology. So the graph, same graph, like making the city map available to travel in a city, something like that. So create the shortest path tree using the Dijkstra's algorithm once if graph is known, and then based on the shortest path tree, we can create the routing table. So you can see procedure of link state routing. It happens like this. First, create states of link at every node, and disseminate means we have to send all the information to all the nodes, and make a topology using the overlapping of knowledge. So partial knowledge is exchanged between the nodes, and based on the common knowledge, they can make a topology like this. For example, this dotted circle indicates A's nodes links, B's node link, C, like that. Every node have a partial information. Every packet is containing node ID, list of links, sequence number, and age. These sequence number and age is to implement the flooding effectively. And why this node ID list of links are required? Partial knowledge is exchanged. A is having three links information, B is having three links information, D is having one link information. So when every LSP packet of all the five nodes are being exchanged through flooding, then every node will get the information from all other nodes so that they can make a common topology. That is the intention behind making these LSPs. And creating the shortest path tree using the Dijkstra's algorithm. So Dijkstra's algorithm is like this basically. Set the root node as a local node. For example, if you wanted to make a routing table for node A here, okay, you make the node A as a root node here. Set root to local node and move it to tentative list. So initially it is moved to tentative list. First, whether the tentative list is empty or not, we have to find out. All the nodes will be initially tentative list only. If all the tentative list are empty, that means no tentative node is found, then it will stop the process. Otherwise, among the nodes in the tentative list, move the one with the shortest path to permanent list. Shortest path, for example, node A to A0, that is the shortest path. Self node will be moved to permanent node. Next shortest will be moved to permanent node. When all the tentative nodes are moved to permanent nodes, it is like this. So add each unprocessed neighbor of last moved node to tentative list if not already there. If a neighbor is in the tentative list with large cumulative cost, then replace it with new, and again every time you have to check is the list empty. So formation of shortest path tree, you can just observe here. I will tell you using the Dijkstra. For example, I am starting with a node A. Okay, so let us suppose I wanted to make a routing table for a node A. I will set the node A as a root node. So A to A will be 0, right? So set A as a root and move A to the tentative list. Initially A is moved to the tentative list. Now in the step 2, what happens? Move A to the permanent list because A to A is shortest path. So A has been moved to the permanent list. Because in the entry, I have to see all the things A to A to B, A to C, A to D. And A is having a direct link between A and B, A and C, and A and D. So what is the shortest path here? A to B is cost 5 and A to C cost 2, A to D cost 3. So what is the shortest one? 2. 2 is a short one. So move A to the permanent list and B, C, D all to the tentative list. What are directly connected to node A? Those are all moved to the tentative list and A is moved to the permanent list. And out of these three, short one we have to take. 3, 2, 5. What is the short one? 2 is a short. So now coming to this. Move C to the permanent list now. So whatever the green color, those are the tentative nodes. The red color nodes are moved to permanent. So initially A was tentative, A is moved to permanent, and A's directly connected nodes B, C, D with a cost 5 to 3 are being moved to the tentative. Then in the next step, third step, C has been moved because out of 3 to 5, 2 is a minimum. Now you have to explore the nodes from C. C to E was 4 earlier, but I am calculating the distance from A, cost from A to E. So A to C 2 and C to E 4, total it is 6. Now the node connected with C is also E, E is also moved to the tentative list after making the C permanent. Now right now A is a permanent and C is a permanent, B, D, E are still tentative. Now we have to go to the next shortest path from A, so to D. Now you see this, and D is also moved to the permanent list, and again B is also moved to the permanent list. Okay, now this is the shortest path tree that has been made basing on the Dijkstra's algorithm. Okay, now so move E is also to the permanent list. So after making the distance, okay, so the distance will be 6 from A. A to B distance was 5, A to C distance is 2, A to E distance is 6 via C. A to D, the distance is 3. Now the tentative list is empty. So all the nodes in the graph are moved to the permanent list. So that this is the shortest path tree. So making use of this shortest path tree, we have to make a routing table. How the routing table is made for a node A? So this is A to A to B, A to C, A to D, A to E. So the shortest path from A to A is 0. There is no need to go via other nodes because it is a self node. And A to B is 5. It is a direct neighbor only. There is no other route shortest for the B from A. And A to C is also direct link with cost 2. A to D is a cost 3. And A to E we can go via C. Because cost for A to C is 2 earlier. C to E was 4. So 2 plus 4, it has been 6. So like that we can make the routing table based on the shortest path tree. Hope everybody understood this. And if you wanted to make a routing table for node B, for example, then we have to start from the node B as a root node, and accordingly we have to make up. Okay, so just before ending, I will just once again tell you what is the criteria for the total link state routing. Link state routing uses the open shortest path first. So there are three major steps. One is creation of states of links, LSPs. Why these are required? In order to send the partial information to all other nodes by using the flooding. Dissemination of these LSPs to all the outgoing paths. That is called flooding. What do you mean by flooding? Say for example, flood means it will go in a downstream only, not upstream. For example, A has a one partial information, A has a link state packet. A will send the information. So if you take this one for example, how flooding is done, I am telling you. A will send its packet to B and to C and to D, all the outgoing paths. Now B, same packet should be forwarded to all the outgoing links except the link in which the packet has come from. So B to C it will send, B to E it will send. It will not send back to A because water will not go up. From where it has come, it will not go there. It will go downstream, similar to that. So there are a lot of duplication. One packet may be received multiple times because multiple nodes will flood them. So that's why sequence numbers are required to avoid the duplicates and to keep the single packet and accordingly making the topology. Okay, so that is how the link state routing will work out. So creation of states of link and flooding is happen and make a topology. After making a topology, then we have to apply the shortest path tree using this procedure. And once if shortest path tree is identified using the procedure of Dijkstra by using tentative list and permanent list, then we can make up a routing table for that node. If at all, if you wanted to make a routing table for node B, starting from node B, we have to create a shortest path tree. Then you have to create a the routing table for node B. Like that, for every other nodes, we can create a routing table. So that's all for today. I hope you have enjoyed the session, this link state routing. Please do subscribe the channel, BYJU'S Exam Prep channel for GATE. And also, you can share with your friends. Do like the session and press the bell button for getting the notifications related to the classes. We are providing a lot of free classes for GATE 2024 and also NIELIT 2023. Please try to make use of this opportunity and share with your friends and do subscribe, and you will get a lot of notifications related to general sessions we are providing and post gate guidance and also some other motivational sessions. Thank you so much. Thank you one and all. Have a nice day. Thank you all.